let's understand the concept behind prime factorization. So the meaning of the prime factorization here, if you're already on this channel, you've probably seen this video, but if you are new here, maybe this is for you. So we already have a short on our channel that explains this in using the process of preparing. Is that this prepare? This is right. So preparing rice, right? I believe everybody knows, right? But here, all that we are going to do here is to divert out to how the manufacturing companies manufacture these phones, right? So it could be an iPhone or maybe a Techno or any other phone, right? Infinix, Samsung, and so on and so forth. So let's take this one away. So the question is, how do they manufacture these things here? So maybe someone may know. So maybe why don't you pause the video and list down those things in the comment section below. For those of us who have no idea on how the technology companies are manufacturing some of these things, right? Okay, now what it means that the process is the most important thing. So the process, right? So you have the process of getting this thing down is the most important thing here. So what do they do? Maybe let's say, for instance, they go for the raw materials. So some of the things that they will need in building up these phones here. So those are the raw materials. And then maybe some engineering, right? So you have some engineering, yeah. So you have engineers or maybe engineering issues here, and then before the final stage, right? So those who test this, so the final. So let's keep that simple. So these are the final. So suppose this is the stage that these phones are some of the phones that we are using goes through, right? So this process is what we are calling a factorization or prime factorization in mathematics. That helps us to determine prime factors. Is that okay? So this is a process that helps us to determine prime factors. Now, away from that, those are the two main keywords that you need to understand in order to have a solid understanding behind what a prime factors are, right? So one is what a prime, and then the second one is what a factor. So since we are dealing with numbers, why don't we add a number to this, making this one prime or numbers? So this is the first one, and then maybe factors of numbers. So now let's understand before you even go to how to factor some of the numbers. Let's say 58 using either factor tree or continuous division, or which I will talk about in this video. So make sure I stay here to the end. You need to understand the meaning of these two words solid before you can even deal with some of these things here. So now, what are prime numbers? So once again, the meaning of the prime factors here are the process, right? So the process of getting prime factors is what we are calling what prime factorization. Is that okay? Now, perfect. So prime numbers here, you see, we have so many numbers, right? So many numbers here. So numbers like, is it numbers everywhere? So let's say $1, or maybe $2, or maybe your currency £2 or whatever, in whatever country you are watching this from, right? So that this is all for you. Something like this is what we are calling numbers. So prime numbers, this one is also a number. So where is needed is the most important thing. Let's say 2.4, or maybe -6, or maybe 3 on 4. All these things are numbers, but which type of numbers are we looking for here? Is that okay? This is a board marker. For sure, this for variation purpose here, this is a black, right? So I have a red here. You see, this is another radius. Even though all are markers, but they have a different variation. So in terms of what color, so this is black, and then this is red. So dealing with numbers here, we have a different types of numbers here. So one of them are what, or is what we are calling what a prime number. So which come out of this prime or factorization here. Is that okay? So prime numbers, these things are whole numbers, right? So another word here. So a whole number, or maybe whole numbers here. Is that okay? Which can only be divided. So one, it must be a whole number, right? So two, it can only be divided by 1 and itself. I believe some of you has ever come across these things here. Is that okay? So a whole number is 1, and then 2, you can only be divided. So let me bring the word divided here. Divided by 1 or itself. Is that okay? We are not just talking about any whole number. So 1, what is the whole number? As I said earlier, a whole number can be something like this, right? So from $1, $2, $3, and so on and so forth. So you also consider 0 to be what? A whole number. Is that okay? So from 0 and then 1, 2, 3, 4, and so on and so forth are what we are calling what? A whole number. Remember, 1.2 here, it's not a whole number. 2.4 is not a whole number. Negative numbers are not a whole numbers or fraction. This even though they are all numbers here, but they are not a whole number, right? So perfect. Now we got the meaning of the whole numbers. So what is the second thing here? The second thing here you must understand here is what? 2. That particular number must be divided by 1 and itself. These are the only things that we are talking about. So to make the thing very, very simple, or to bring or to cut the long talk here very, very simple or short here. So if you have an amount of, let's say, $6 here, and I want to share this thing, that's the meaning, right? So I want to donate. That is normally what donation. So you have donate. You want to donate these two to maybe, let's say, just one person, just one person. What do you think will be the values of that person? So how much this is the total amount, right? So this is the total amount, which is $6. How much is that person going to take? The person takes all. That's just $6. Is that okay? Right? Because there's no any other person for this particular guy to share the $6 with. So that person takes all the money. Right? Okay, remember the second one says that for sure we've already come across or meet this requirement here that says that we should divide that whole number by 1. The second one is by itself, right? So it is a whole number. It is so the answer that we got here is going to be a whole number. Is it indeed that this thing is a whole number? Yes, of course it is what? A whole number. Is that okay? This is a whole number because it doesn't have any points ahead. Maybe mathematically that is a decimal, or it doesn't have any fraction form. So once again, is this $6 can be divided by itself. So maybe let's say among 6 people, right? Or 6 people, right? For sure, if I'm going to divide this $6, I want to donate this to maybe some children, or maybe anybody that you want to give this thing. So obviously, if I'm going to share this thing among 6 people, each person is just going to take $1. Does it make sense? Yeah, very so what would be the answer? And the answer that I'm having here is just $1, right? So 1 here is 1 a whole number. For sure, it is a whole number. Is that okay? It is a whole number because it doesn't have any negative decimal point or fraction and so on and so forth. So these are the two things that we are calling what? Let's say these are the two things that we are calling what? A prime number. But remember, there's one thing here. Can we have another number that we can divide the 6 by, right? So can we divide? Yes, for sure. If I I want to share this among 2 people here, the answer that I'm going to have is still $3, right? So this one also qualifies. So in the long run, yes, 6 is not what a prime number because it doesn't qualify, or it doesn't meet the requirements of what a prime number. Remember, it says that a whole number 1, and then you must divide it by 1, and then what? And yourself. Is that okay? So here we are having what? 3 people. That is 1, and then we have another 6, and then we have another 2 here. I believe this one self can be divided by 3, right? So it seems that we have more people here. So this is not what a prime number. So avoid some of these mistakes what in your mathematics. So now let's see examples of a prime numbers here. So now let's consider 2. That's the easiest one. So let's consider 2 here. So is 2 a prime number? How can we identify that this is a prime number? So to identify that, we know that 1, you must be divided by yourself, and then 2, and then you must be divided by 1, right? So here, if I divide this one by 1, I'm going to have 2, which is a whole number. Is that okay? Because a prime number is a whole number. So I'm going to have what? If I divide this one by this 2 by 1, I'm going to have a 1. So of course, this 1 here is a whole number here. So what will happen? Let's check the second one. So what will happen if I divide 2 by 2 here? I'm going to have 1. This 1 here is also a whole number. You see the trend here. The number just turned upside down, right? So 2 divided by 1 gives me another 2 here. And 2 divided by 2 here gives me what? Another 1. Is that okay? So the answer that I'm going to have, this is a whole number, and then this is a whole number. Does it make sense? So this 2 here is a prime, or maybe you have another number. If you divide by, or maybe if I divide that number by 2, I'm going to have, let's say 2 divided by 3. am I going to have a whole number? Because now you know the meaning or the definitions of a whole number from the previous part here. Okay, am I going to have a whole number? That is the question. If this thing is not, this condition is not met, then one of the requirements for a prime number is not satisfied. So for sure, this is not a prime number. So now talking about the factors here, so is that okay? So talking about the factor here, this is another thing that you must pay very, very close attention. So the factors of any number here, so let's restrict ourselves to these two, because understanding the basic makes you a better person to solve a very complex problem, right? Okay, so when I restrict myself to these two here, is okay. So factors of 2 here, what we are trying to say here is that what are some of the numbers, what are some of the two things that if you multiply, I'm going to have these 2 here, right? So this is too technical. Let's understand it in this way. So finding the factors of any number, that is exactly what we are trying to do here. Is if you have these $2 here, right? So if you have $2 here, I want to find the factors of these two particular dollars here. And then which numbers am I going to multiply to have my $2? That is very, very simple and straightforward. Is that okay? Let's look at it from this angle. Okay, so which numbers, if I multiply, I'm going to have $2. I like normally use the word times, right? So how many times am I going to multiply something to have my 2 here? Well, this is just one time. So $1 here, $1 can be multiplied by just 1, right? So if you are multiply, 2 times 1, right? So 2 times 1 is just going to give me these $2. Yeah? So meaning that I'm having a $2 how many times? Only one time. So is there any number, that is the question, is there any number here if I multiply by this my 2 here, or if is there any two different number if I multiply them, I'm going to have my $2? So that is the question here, right? So that's the very big question, right? That's a very simple answer. Like, of course, no, I don't have any. If you have a number, why don't you comment this thing? If you have any number multiplied by itself here, for sure that number has to be somewhere a positive, depending on what we are dealing with, right? There's no number here apart from 1. So we say that, or maybe 2, right? So 2 multiplied by another 1 here is going to be 2, right? So that's the $2. So if there's a different number here, just make sure that you comment that number in the comment section below, right? So these are the two strong factors of 1. So the factors of 2. So the factors of these 2 here are just going to be 1 and then 2. So that is how we got a factor. So those numbers that if I multiply these two, I'm going to have my original amount. So I'm calling this one amount for understanding purpose. So I'm going to have my original number here. So it could be more than that. So if I say something like a 9 here, which two numbers or numbers that if I multiply, I'm going to have this for sure. 1 and then 9 is 1. Is that okay? And then what again? And then 3 by itself is also another thing here. Is that correct? So given the values of this thing, if this is what a factors of 9, let me know this thing in the comment section below, right? So that tells me that you are participating. Now let's look at a whole question on how to factorize a prime factorization using two different methods here. By the way, if you are getting some values from this video, make sure that you subscribe to the channel if you haven't. If you're already here, so give us a thumbs up, comment in the comment section below if you have any questions. There are two basic ways, so these are two basic ways of getting these prime factors. So maybe prime factorization, we know what it means by now. So the question here, the first one here is exactly what we call, most of us know, so a factor tree, right? So a factor tree, and then the second one is the one continuous division. So these are the two basic things that we need, or we are going to use in finding the prime factorization. So this is very simple. So if I want to write against this whiteboard here, this is what I have at my disposal, right? A board marker. So I'm using a board marker to write against this whiteboard, or maybe I may go for a permanent marker. So maybe that is another way here. So if I don't want to wipe it, right? So if I don't want to wipe it again, you see these things here is that if you are right, I can easily clean it, right? So with a permanent marker, that will be very difficult to clean here. So that is another way. So the best way here to write against the whiteboard here is to use a border a board marker, right? So the best way to find the factor or prime factors of or prime factorization are two. So one is the prime factor, and then the second one is a continuous division. Now, this is my question for you: what is the importance of this thing in real life? So let me know. This is just a very simple question, right? So what is the importance of learning this prime factorization in the real life? Right, so maybe you may comment the value or the importance of learning this thing in the comment section. Maybe that will help a lot of the students here. Let's do the discussion in the comment section, right? So that's very, very important. Okay, so let's begin with the first one, which is a factor tree. Now, so talking about a factor tree, so we know the meaning of the factor. So we are coming to find the prime factors here, right? So the prime factors. So a tree is something that you already know. So that is the nature of the thing, right? So here, let's say, assuming we have 28, and then we want to find the prime factors, right? So the factors of this 28. Is that okay? Remember, we are not just going to find any numbers out of this, but specifically that is the prime numbers, right? So the prime factors of this 2018. So using this method is what we are calling what? The factor tree. So how do you determine that? So now the first step in finding this thing using the factor tree is to determine the first simple prime number. Of course, that is going to be 2, right? So 2, now we know that 2 is a prime number based on our previous example. So now the key here is that factors, right? So this factor here, we've already seen that this factor is those two numbers that if you multiply, we are going to have what? This 28. This is our original number. So this is the amount that we are having. Let's say 28. What are the two? We want to split that into two using what the prime numbers is. So, okay. So what are the two numbers that if I multiply them, I'm going to have on my 28? For sure, one of them has to be what? A prime. A prime. Is that okay? So that is the 2 here. So 2 by 14 here is obviously going to be what? 28, right? So now that we got a one prime number, you focus on the second one. Which one? Is this one a prime number? No, this is not a prime number. The question here is why? Because you know the definitions of a prime number. I can have so many numbers that if I multiply them by itself, I'm going to have a 14. One of them is 1 and 14. I'm going to have 1, 2, and 7. So even with this one tells me that this is not a prime number. Why? Because the definitions of a prime number is saying that I can only have two factors, that is the 1 and the number itself, or it can only be divided by that number and the number itself. Because here 14 can be divided by 1, and then 14 can be divided by 2, as well as 40 can be divided by 7. Is that okay? Once I have more than this thing here, this is not a prime number. So since this is not a prime number, we have to break this guy down again with what? Our prime number. So the smallest one again, that's going to be 7. So my personal advice is to always focus on what? The smallest prime number here. Is that okay? So 2 by 7 here is going to be 14, which is my original number. We don't have anything to do with this 28 again. So don't go back here. Is that okay? Once we are done with the first step, we are free to go. So here I have this thing here. So here among these two, do I have any prime number here again? That is the question. You just need to check this. This is a prime number. What about this one? Is this one a prime number or a different type of number, which is a composite? That is just for another video. Is that okay? So maybe that is why you need to subscribe to the channel if you haven't done that, right? So perfect. Is this one a prime number? That's the question you should be asking. So you just need to check if you have 7 divided by 1 for sure, because that's the definition. So 1 here is going to be 7, and then what about 7 divided by itself? It's also going to be 1. Do I have any number that if I divide by 7, I'm going to have a whole number here? And that is the whole idea here. Maybe you have that number here, but for me, I don't have that number. So this one is what a prime number. So we are going to end here because you have seen our last prime number. So the way of writing the solution to this thing is just going to be the smallest number here. That's the 2 multiplied by 2, and then what? Multiplied by 7. Does it make sense? So that is very, very simple, right? So these are the prime trees. So now with the same example, someone will go for a different number here. So let's see that. So let me try and manage or put myself in this idea. So I have a 28 here. We want to find the prime factors of 28. So someone may start by saying that, okay, what will happen if I say 7 by 4. So always, if you have chosen your number, make sure that you have one of the prime numbers. So you can only do this thing if you have your prime numbers, or the other way around. So this could be 4 and 7. Nobody is going to arrest you for doing this for sure. So this one is going to give me my original number, which is 28 here. So among these two, which one is a prime number? 7 is a prime number. Maybe from this example, you've seen that 7 is a prime number. What about 4? 4 is not a prime number. Why? Because if I divide 4 by 1, I'm going to have 4. If I divide 4 by 4, I'm going to have 1, which of course these things are whole numbers here. And then what will happen if I divide 4 by 2 here? So this is going to be 2. Because since I'm having 3 devices here, so maybe I divided by 3 things here, this is not a prime number, because the definition says you can only divide that number by 1 and then by yourself, right? So this is not a prime number. So you need to break this one down here. So breaking this guy down here is going to be the smallest prime number, that's the 2, and then multiply by 2 here. So 2 by 2 is still going to give you what? My 4 here. Does it make sense? Is there any another thing that I can break this guy? No, this is just a prime number from the previous example. So our definition here is the same. Obviously we are having, so you need to write the solution in terms of the prime numbers, right? So those are the prime factors. So that's the 2 multiplied by 2. What is the another prime factor? Then multiply by 7. So if this one and this one are the same, so whichever way you go, you should arrive at the same answer. Is that okay? All right. So now what maybe this is for you. So check this example is for you. So we'll find the prime factors, or the prime factors of this guy. That's the 54. And then as well as, so you have 18 here. Is that okay? These are the two things you have to. So mention this thing in the comment section below, the values of these, or the prime factors of these things, in the comment section below. Oh, now talking about the second we are finding the prime factors, or the prime factorizations of a given number here. So that's the continuous division. So as the name implies, we are going to divide a number continuously. It's not a long division. This may be a different from a long division. So stay here to the end of the video. The first example that we are going to do using the continuous division here is that let's focus on 72, right? So picking a number, this is just a random number. Is that okay? So picking this number here, you want to find the prime factors with this method here. That is the continuous division. So what we are going to do here, you draw this line here. You see this line, this is somehow L symbol. This is just a process of getting the prime numbers done. So by is the division. So here someone will go, so the first prime number, or maybe the number, remember we are looking for the prime number. It's very important to deal with the basic prime number. So my advice here is always to start with a 2, a 3, because I know that those things are prime numbers. Is that okay? 2, 3, and so on and so forth. So here dealing with 2 here, is that okay? So 2 divided by this thing, I'm going to have my answer to be, is that 36? So I'm having a 36 here. So with this 36, I know that I've got one prime number. So let's continue the division here again. So which number are we going to use to divide this thing here with? So of course, so let's focus on the 2. So dealing with the 2, I'm going to have my answer to be 18. Is that okay? So still dividing this one continuously. So if I divide this one by, so 18 divided by 2 here, I'm going to have 9. So once I have my 9 here, obviously the trend is very simple. So you have to do this thing. So mathematics is all about practicing. So once you practice, you'll be very, there's no magic way of getting mathematics. So if you keep on saying math is difficult, to be difficult in your head rather than be on the paper. So keep on trying, also you succeed. Is that okay? So no fear of losing, or no fear of making mistakes here. Right? So here we have a 9. So 9 here, which number are you going to, which prime number? You say for sure 2 cannot divide by this 9 here. So 2 divided this one here, I'm going to have 4.5, which is not a prime number. Assuming. So we are assuming that we are dividing this one by 2. So if you divide this 2 by 2, I'm going to have 4.5. Remember the definitions of a prime number. This thing is not a prime number, because the answer must be a whole number. Is that okay? So 2 is not the best answer here. So here, let's go for 3. So 3 divided this one by, we are going to have a 3 here again. Is that okay? So once we have this 3 here, is there any number? Of course, this is a prime number, right? So this is not any different number here, right? Okay, so since this is going to be our last prime number, so the arrangement here is going to be 2 from the top here, by 2, by another 2, and then by 3, and then by 3. right? So this is a key here. If you stay here by this time, this is a key for you. So here, if you want to write this thing in index form, right? So index form, that is 2 raised to the power 3, because the 3 are how many? 3 here. The 2 are 3, and then multiply by 2. Sorry, multiply by 3 here. So 3 raised to the power what? Raised to the power 2. Does it make sense? So that is what in the index form. So but if you have not been asked to write this thing in the index form, nobody is going to arrest you for doing it in this way. Is that okay? Okay, perfect. And now what will happen if another person will go for a different number altogether, right? So maybe one person can stand here instead of 2 here, that person is going to deal with 3. Let's see that. So if another person decided to go this way, so we have the 72 and then divided by, instead of 2, that person goes for 3. For sure, 3 is a prime number, right? So you know that 3 is a basic prime number here. And then so 3 divided by 72 here, I'm going to have a 24, right? So 24 here. So with this 24 is not a prime number. So breaking this thing down here, if you have any question, just make sure that you comment below, right? It's very, very important. So 24 here, which number? So 3 here can still divided by 24. So I'm going to have 8, right? So 8 here. So if you don't know the meaning of this division, once again, it's very, very important to question or make sure that you bring your question in the comment section below. Once again, if you are new here, don't hesitate to subscribe to the channel. Comment in the comment section if you have any issue. Then if you are getting some value from this video, why don't you give us a thumbs up, right? So this will help us to promote a better video in the future for you. Now here, what to be the next thing? Remember, 2 can be divided by what? By 8, right? So if you are divided to, or maybe 4 can be divided by 8. Let's say 4 can be divided. So if you choose 4 here, this 4 here, it is not a prime number. So be very, very careful when you are choosing your numbers that you are going to divide with. So here, because 3 cannot be divided by 8 here, so let's go for 2. So I'm going to have my answer to be 4, right? So 4 here. So 2 can be divided is by 4. So I have 2. Is that okay? So sometimes the choice of the numbers are in your court, right? So you have to pay very close attention when you are dealing with or some of these to make sure that the numbers that you are choosing are prime, right? So they are prime or number. You know the definitions of a prime. In case you forget that you cannot remember the definitions of a prime, that's the number that you divide by yourself and then by 1, right, to have a whole number answer. So looking at writing this thing here, it's just going to be, you see, the same as this 2 multiply by 2 and then multiply by another 2 here, and multiply by 3 and then multiply by 3, right? Okay, let me write this thing. Have you seen that it's almost the same? 1 and then 2 and then we have this and then we have this one, the same as the one that we have from the previous part. Is that okay? All right. So the final part of this video is to determine the GCF, the greatest common factor, right? So talking about the greatest common factor, that will be for another video. So make sure that you subscribe to the channel if you want to see more of these videos in the future. Thank you for watching.